in business and industry, produced each week by the National Association of Manufacturers.
Out of one of the nation's 150 Portland cement plants rolls another load of one of the most vital building materials now urgently in demand. This plant, largest of the 150, is neither in Portland, Oregon, nor in Portland, Maine. It's the plant of the Huron Portland Cement Company, and it's in Alpena, Michigan, just about halfway in between. Cement plants are built near the sources of their raw materials, and this limestone quarry of the Wyandotte Chemicals Corporation provides Huron with one of the 3 or 4 basic ingredients of Portland cement. Other materials that go into Portland cement include silica, alumina, iron oxide, gypsum, and shale. In recent conservation experiments, the slag from blast furnaces has been found to be a suitable substitute for shale. The raw materials go first to the primary crushers, where the big boulders are knocked down to more convenient size. Eventually, before they leave the plant in the form of cement, the huge chunks of rock will be reduced to a powder that will pass through a sieve so fine it will hold water. From the primary crusher, skip cars haul the materials up to a conveyor belt that takes them on to other crushers and hammer mills. The conveyor that rolls endlessly toward the main plant is covered to prevent the wind from whipping crushed rock over the countryside. Control of dust is a problem the engineers of this vast establishment must work constantly to master. Moving along mechanically from one operation to the next, the raw materials are brought closer and closer to the form of powder. Finally, they're fed into a rotary kiln, where they meet a roaring blast of flame with a temperature of more than 2,700 degrees Fahrenheit. Inside the slowly revolving kilns, certain elements are driven off, while the others, as they move from one end to the other, are fused into a new substance called clinker. After cooling, a new grinding is necessary, and the product that results is Portland cement. Into the holds of ships go thousands of tons of the powder daily, destined like as not for Portland, Maine or Portland, Oregon. For Portland cement was named not for any city, but for a certain stone it resembles, a stone to be found on the Isle of Portland off the British coast. Away goes another full cargo to meet a constantly increasing need for cement in the construction of homes, factories, highways, and nearly every other structure of peace or war.
The pioneering days of perilous journeys in covered wagons have gone, but in their place have come exciting challenges of new and undreamed of scientific and industrial developments. Developments that demand imagination, skill, and purpose in the same way that the untamed wilderness demanded courage and stamina. These developments, the continuing wealth of new products, new processes, and new industries, are the direct result of our ability to keep our personal lives, our institutions, and our whole business system free. The American way.
Inside this vine-covered factory at Hagerstown, Maryland, the Brandt Cabinet works. Craftsmen go about their duties in what might be described as the labor of love. Take Randall Hawes. He's been doing expert cabinet work here for 45 years. What's more, Randall has 3 sons employed by Brandt, and they too have been here a long time. Harry, for example, here fashioning a tabletop, has been on the job for 28 years. John Hawes' service extends over 30 years. His dad made a satisfying career out of it, and so has John. And here's the 3rd son, Arthur. He's been at Brandt only 20 years. You might say he hardly knows his way around, but he does know what goes under the table legs. Brandt's claim is that it makes furniture of quality, but it also makes something else, men of quality. For in addition to its many old-timers, Brandt also employs a number of men who, though along in years, are just beginning their careers. Not pictured, but working here and there in the plant, are a few ex-convicts and some former heavy drinkers who have got back on their feet through Alcoholics Anonymous. They're all on an equal basis with this veteran employee, responsible citizens of the community, and they're responding in excellent fashion. A casual visitor to the plant couldn't possibly pick out the men who are getting that second chance, and one thing is certain, no one here will point them out for you. Whether they've been at Brandt's for 45 years or are just beginning to live anew, they're all craftsmen together, and all that matters is what kind of fellow worker you turn out to be.
The National Plastic Products Company plant at Odenton, Maryland. A firm that plays one specialized part in the manufacture of a product that makes life a little easier and better for all of us. Arriving at the Odenton factory daily come tons of a white plastic powder called Saran, made from petroleum and brine pumped out of deep underground lakes in the south. The Dow Chemical Company produced the Saran powder. Now, National Plastic Products will further process it, add pigments, and extrude or spin it into a fiber that can be woven like cloth. Here, National Plastic Products will not do the weaving. It sticks to the job it does best, leaving earlier and later phases of the manufacturing operation to firms that have the expert know-how in those fields. Out of the extruders come heavy strands of plastic, which cooled in water and drawn out, become thinner and thinner. Finally, the Saran becomes a strong filament, 15 thousandths of an inch in diameter. It can now be handled in much the same manner as you would handle thread, but its color is built in, and it has uses to which thread could never be put. Now it moves on to another city in another state for the next step in its development. The Lumite division of the Chicopee Manufacturing Corporation of Georgia is the company that finally transforms the Saran into products that will be used by the consumers. First, some of the fiber is rewound onto bobbins that will shuttle back and forth in the weaving to make the cross strands. Other spools are put on a creel to be rewound onto much larger rolls. They'll feed the fibers that run longitudinally. Chicopee has had long experience as a manufacturer of cotton cloth, so the changeover to weaving plastic fabrics was accomplished with a minimum of confusion. About once every 2 days, the roll of Saran thread for the warp must be renewed, and a mechanical tire joins every strand in only a few minutes. It's here, for example, that a company like Lumite is able to take advantage of knowledge gained in generations of practice in allied fields. Once everything is ready, the loom goes into action. And the end product, not cloth as you think of it in this case, although elsewhere in the plant the plastic is woven into fabrics for a variety of uses. This is insect screen cloth, with some surprising advantages over the usual screening materials. Completely rust and corrosion resistant, it requires no protective painting, since its color is built in. Strong, light, and taut, the armed forces preferred it above all others during World War II, especially in the tropics. Now, even when used in areas right near the water, it's doing a standout job for the American homeowner. Around this particular household, where there also appears to be a shortage of manpower, it's Lumite screen cloth to the rescue.
Inflation is not new. It has existed since ancient times and has hit nearly every country in the world. In America, we've experienced inflation for the past dozen years. Inflation caused by government debt and easy credit policies which cut the value of our dollar nearly in half. The way to stop inflation is to increase production, reduce government spending, curb private and public credit policies from making inflationary loans, and put the cost of government, including defense spending, on a pay-as-we-go basis by adopting a sound tax policy. We must lick inflation.
What strange new product is being produced here? It's nothing stranger or newer than all-day suckers with a safety handle. We're in the Chicago plant of the Curtis Candy Company, where the job of making the suckers, candy bars, and other sweet tooth satisfiers is no longer one of back-breaking manual labor. Now, millions of pieces are produced each day, all uniform in taste and purity. Stirring used to be a real chore, as anyone who's cooked a batch of fudge can testify, but no longer. What looks like a weaving snake is really an endless roll of candy being squeezed smaller and smaller until it enters a shearing machine that transforms it into fruit drops. Wrapped in tinfoil by machine, the packs get their bright paper wrappers in the same way. But skilled human hands are still best for putting the packs in boxes, for even the best of machines cannot detect slight imperfections. But now we move on to the department where, from great tanks of chocolate, milk, and other nutritious farm products, the men and women of Curtis draw the materials for the firm's most famous item, the Baby Ruth candy bar. Here are formed, first of all, the fudge cores. Molds are powdered with cornstarch. Then in pours the fudge. After hardening overnight, the cores are ready for the next phase of the operation, which involves having a thick layer of freshly roasted peanuts pressed into them. Then it's right on into the machine where they're coated with rich milk chocolate. When the chocolate's dry, the bars go into their wrappers in groups of 10, which makes for easier packaging. The wrappers then are sealed, again, 10 at a time. Once they're in their boxes, the bars must keep moving toward the consumer. For to make sure that its product will be fresh, Curtis, although it manufactures hundreds of thousands of pounds of candy each day, retains none of it in storage. It's a practice the customers seem to like.